Welcome to Inside Startup Investing, the only podcast where you can invest in every guest. On this episode, I will be speaking with the founder and CEO of Atombeam, Charles Yeoman. The best way I can think of to describe Atombeam is to take an example from the movie Back to the Future. If you remember, in Back to the Future 2, Marty McFly's wife puts a dehydrated pizza into a rehydrating oven and takes this tiny little pizza out of a box. When it comes out of the rehydrating oven, it's a large, piping hot pizza. So imagine a tractor trailer that needs to carry frozen pizzas to a store, and it can carry 1,000 of them in a trailer. But if it had this dehydrating technology, that compacted pizza could probably fit over 100,000 pizzas in a trailer. Producers and distributors would line up for that type of technology in a second because of the throughput that you can actually get from compacting those pizzas. Well, to apply this to what Atombeam is doing, essentially what they've created is AI-powered compaction software that can reduce the size of data that needs to be transmitted by many orders of magnitude, so more data can be sent and processed in a better, faster, cheaper way. In a world where every device is now smart, think your home thermometer, refrigerator, even outlet, data compaction technology has never been more important in order to enable all of these smart devices to perform at a high level. And it's not just smart devices, it's really the world around us, from the front lines of the military to satellite technology and more. Essentially, if you can process more data in a faster, more energy efficient way, the opportunities to monetize that technology are quite large. Atombeam has invested tens of millions of dollars to build this data compaction capability and is beginning to really commercialize the business through its NERPAC offering. While I think there is a ways to go to scale revenues where they will need to be to lead to an outstanding outcome for investors, they are making real, measurable headway that excites me about the near-term commercial opportunity. So with that, let's get on to the show and hear what Charles has to say about the future of Atombeam. Charles, thanks so much for being here today.
My pleasure. Thanks for having me, Chris.
Yeah, no, I'm excited for this one. You've certainly been very active in the Reg CF and Reg A markets and raised a lot of money from a lot of folks. And you're doing some really, really interesting things that are probably a little bit above my pay grade, but let's get into it. Tell us a little bit about what Atombeam actually is.
Fundamentally, we're a software company. We have two products. One is a product that's out in the market, moves millions of transactions a day. That one's called NERPAC, and I'll tell you about it in a little more detail. But fundamentally, what it does is it, in typical circumstances, can quadruple the amount of data that moves through the same hardware, the same network. And, given the amount of data that's going on and it's growing so much, then that's a big deal. The other thing we do, and this one's still in development, is we have an AI. It does not use transformers, which every other generative AI does.
All right, so let's get into the first product a little bit. What are the applications of this? Why do people need this?
Sure. Yeah, so there's basically three main categories that NERPAC applies to, and it's called NERPAC. One is the one that we're applying it to right now is for IoT, Internet of Things type stuff, and it's growing really fast. I mean, you can find all sorts of increases out there, but the estimates out there are like 30-40% a year growth in that amount of data that's getting generated. And if you have a device that's out on the edge that's moving data, it could be a car, it could be a smart meter, it could be an ATM. All those things need to move data, and everybody who uses them wants more data. And so how do you do it? Well, I could either replace my network with a new network, which is pretty pricey, or you can install our software, which is a cool little thing on the edge that works in just about everything. It can work on a 10-cent chip. And so as a result, all these things that are out there that need to send all this data, 95% of it, by some estimates, most estimates, 95% of it just can't move because there's just too much of it. So all the stuff that gets generated on the edge, 95% of it doesn't go anywhere. And the rest of it, is growing really fast. You can't move it. How do you get it to where you want it to go? And so that's what we do. And we can usually quadruple the effective bandwidth, which means you can get 4 times more data to where you want it.
I want to get a real life example to help people picture what this actually does. So just throwing something out there. Say you have, a Tesla car, right, that drives itself. It's obviously collecting millions of data points probably every second to know, where the other vehicles are and if people are coming in front of you, this, that, and the other thing. It takes in all that information, and then the way that it works is it has to be processed, right? And are you saying that 95% of that data that's being collected in a Tesla car, instead of shooting it up to some satellite and getting information back and then shooting it back, that's not possible or just deeply inefficient, and that you can manage that data on site? Give us some sense what that looks like.
So some of it needs to be processed right there in the car, right?
Yep.
I don't have time to send something off to Timbuktu and get it back, what to do or something. So yeah, most of it is actually processed in the car. But, typical modern car generates, and I don't know about Tesla in particular, but typical modern car generates about 25 gigabits per hour. And the capacity of the network to send that is about 1% of that in the case of cars. And so, but the thing to think about with cars in particular is it's not it's not sort of saying, okay, we're going to trim down the amount of data. No, you got smart roads, you got what's the transportation department calls the V2X, vehicle to whatever, and talking to other cars, and increasingly talking to the road, talking to whatever. All those things are out there, and that means you need more bandwidth, and you can't sort of just expand it to whatever you want it to be, because there's a lot of other cars that are using that same bandwidth, as well as people, as well as whatever. So, they're racing to get 6G done, but that won't be done for years. And in the meantime, we can translate this stuff. So what we do is we take whatever the data is that's coming out of a machine, and we have a little code book, and the code book says, when you find this pattern, substitute a little code word that represents the pattern. So the pattern might be 128 bits, for example, and code word might be 3 bits or 10 bits. It depends how frequently you find that particular pattern. So when you do that, it swaps it out in a few microseconds, and then sends it off to wherever it goes, and then it just, the other side has the same code book, same little code ring, and it swaps it back into the original. For instance, like a satellite, big satellite company said to us recently, well, so this is like, for every satellite I've got up there, this is like launching 3 more. And effective, yeah, that's what you're doing. But it's a heck of a lot cheaper than sending up even LEO satellites. So
you're taking a lot of information, making it into a smaller bit that requires less bandwidth to move, shooting it off, and then re-expanding it on the other end.
Exactly.
Is that a really simplistic way of thinking about that?
Yeah.
Super interesting. What was the breakthrough here where you went, whoa, we have a technology unlike anything else that's out there, and this could really be powerful?
Yeah, well, at first it was a really cool idea, and we started this thing in the company, and we didn't understand that IoT was like the first target at first. And then pretty quickly, though, we figured it out, because IoT is like, it's growing like that. And so how do you deal with all the data that's coming out of everything? Cars, airplanes, trucks, the manufacturing, mining, all this stuff. wells, all that stuff is multiplying. And so what do you do? And so, we started, getting people pushing us to say, hey, we could really use this. Some of the first ones were mines in Chile that needed to send more data from Chile over to, I can't remember wherever the data center was. But they were sending it over satellites because they're out in the middle of the boonies, right? And so that all started to roll up. Then, we have other applications for this stuff. I'm happy to tell you about them, but the IoT thing is the first thing, but the other stuff could be even bigger.
Maybe to just take a step back, tell me a little bit about your background, how you found yourself here in this position, and a little bit more about the team, because when it comes to something as sophisticated as this, obviously it's the people behind it. So I'd love to understand that a little more.
I was Navy intelligence officer, went to Stanford for my MBA after that, and worked on Wall Street for a number of years. It's been really helpful understanding sort of like how finance works and everything, and money raising and all that business. But I got tired of just moving the money. I wanted to be one of the guys moving the money for. And so I took a job as a COO in a company in New York, pretty good sized, little mid-sized company. After that, I was recruited by a PE fund to take over as CEO of a company. Ran another company, and now running this. So, and the team we have some really experienced guys. Like the guy who runs engineering is PhD from Purdue, has experience as VP with like 1,000+ people under him at Akamai and at Ericsson. CFO was CFO of some various companies in Silicon Valley, is taking companies public. Most people don't get is what it takes to move something that's a great idea and really works in the lab to a real product that people actually use, that big companies are willing to use. That's the heavy lift. I mean, there's lots of good ideas, right? But those turning into products, especially in tech,
execution is where it all comes down. Yep, ideas are a dime a dozen. Well, getting to that point, where are you guys in terms of commercialization? What do your customers look like today? And I'd really like to understand how you're thinking about scaling revenues from, about $1 million a year to 10 million, 100 million, $200 million.
So just to be clear, what we did was we built a SaaS version of NERPAC. Because we were getting market indications that said, yeah, that would be good and all that stuff. It turned out those were not real. We really needed on-prem. We needed something that people install in their gadget, their smart meter, their car, or their whatever. That is where we took it next. We just came out with that version in December. And we got a pretty good long line of people who want to use it. It's being used right now in Saudi Arabia for fintech. It's being used, for oil and gas company to send data from a well over satellites. We're close to inking a deal with a pretty good sized company that does smart grids, smart meters. They regard it as like this could be a huge deal for them. They see it as, they think this could be a major line of business because in that whole industry, they plan on reselling it to their competitors, because in that whole industry there's a desperate need for more bandwidth. You can't do it, or it's too expensive. It's one of those two things, and we fix it, like very neatly, and we even add security. We can even add encryption to it if they want, which 98% of IoT doesn't have any security at all, and it's a huge problem, and we're fixing that, with our little NERPAC gadget. So it's pretty cool. And down the road, one of the cool things about this is, because I explained the code word thing, If you have the code book and you load it into the RAM of a server, all of the data that was encoded with that code book is now visible, usable, searchable, randomly accessible. That's not possible with compressed data. So if you take the data, swish it down by 75% on average, and all that data is now usable, that means that, say, a database could potentially be a quarter of the size it is, which means that data can be searched faster. Whatever these guys want, they want faster databases, right? It's a huge issue. We can potentially address that. But the biggest thing we think in the future would be moving data in a data center faster. It's, like when you think about like what goes on in these data centers with GPUs spend, and it depends on what aspect of it, 30 to 80% of their time doing nothing. They're just sitting there sucking up power. It's a huge utilization issue. And the reason that's true is they can't get the data to the GPU. We can potentially fix that. That could be a massive opportunity for us. Because, again, we can do the swap for these code words super fast. And that means you really can speed the data.
So in terms of let's talk about near to midterm kind of sales and growth strategy, what does your sales team look like? Who is the point of contact or person you're selling to? And how long do these contracts take? And once you win them, are these 6-figure contracts, 7-figure contracts?
We have 2 dedicated salespeople. We have a partner person who understands partnerships and how to make them work best. We have others who are right there supporting them. Some are product guys, and everybody's very focused on revenue right now, as they should be forever. But that's the structure right now. I get involved directly in stuff. To talk a little about the smart meter thing as an example. So there are about it depends how you read, 1.5 to 2 billion smart meters in the world. And it's a very international business. You might have stuff in the US and in Malaysia or something. That's an example of there's a whole lot of them, but the amount of data they move is teeny, which means that we charge a few cents a month per meter. But if you were to compare that to like a container ship sending data over satellites, that's not a few cents a month. That's a lot more. But to go back to the smart meter idea, the smart meter thing. So right now, they think they're going to win a new installation. It'll be 8 million smart meters. 8 million means that we would be in all of them probably. It would take a couple of years for it to happen. First you got to negotiate the deal with the smart meter company, and then they go forward with us and so forth. And then they start to address both their installed base, as well as, which is millions, as well as these new opportunities, as well as their competitors. Their intent is to make it into an industry standard. They believe that'll happen in a few years. So if you were to say, how big is the 8 million smart meter thing? It's definitely millions. A smaller installation might be in the hundreds of thousands. Because you're talking utilities, and you're talking about, in most cases, millions of things. So, that would be a fairly typical. Whereas, something like fintech might be in the tens of thousands or hundreds of thousands, and because they don't need as much stuff. So it's going to vary all over the map. It just is how it works.
It almost feels like one of your challenges as a business is there's a lot of potential end applications, some really massive, some a bit smaller. How do you decide where to focus your attention and pursue? Because I mean, it sounds like smart meters could take years to really roll out. Versus something like fintech, you could be up and running probably in a matter of weeks. But how are you managing that strategy?
A lot of what our emphasis is, and when we sit in our sales meetings, is all right, I don't want to turn off the big stuff that
Mm-hmm.
takes a long time, but we spend 2/3 of the time, I would guess, focused on what can close in the next 60 days. We need revenue now. I mean, at the same time, you don't want to tell somebody like, a major company in South Korea that wants to, is interested in potentially putting it into their ECUs. You don't want to tell them, no, I'm not interested. So
Sure.
it's a balance. It's not as simple as like, oh, let's just only focus on new stuff. A lot of it is vertically focused. Like, where do we have the most resonance?
Mm.
This one, and this one. Not as much over here and here. A lot of those things that are the not as much ones will come around, but they have a higher bar, that we need to get over first.
When you look at the competitive landscape, are there other solutions out there like you? And if so, how do you differentiate?
Well, we've never seen anything. We have over 100 patents for NERPAC, and it would be very challenging for somebody to say, yeah, I'm going to go ahead and make something that's just very similar. We have very smart patent people, and we are covered 6 ways from Sunday. We've also never run into anything that looks like this. I mean, the closest thing would be dictionary-based compression, but there's fundamental differences there that, for instance, like, you got to think of it as like compression is like, that's file-based. You look at a file, you look for repetitions of pattern, and you put in placeholders where you see a repeat. And what we're doing is we're looking at little chunks of data as it streams, and we're smishing them down to about a quarter of their size. And so it's streaming compaction. That's what we think of it, versus compressing files.
Mm.
It's fundamentally different. And so that's why we can work on all sorts of things. Like, NASA's talking to us, they're really interested. Why? How can you send data from, Mars to here more efficiently, faster?
Hmm.
I mean, the amount of bandwidth they've got is minuscule. You suffer, like, they have this DSN, the Deep Space Network, this giant antennas. They're trying to pick up something that's basically a 20-watt light bulb kind of power out in Pluto. It's not freaking easy, and the amount of error correction is huge and everything. So we can help them a lot, and they see it, but they're not super fast. Most of our revenue to date has come from defense. We've had 7 contracts. We have one going with the Space Force right now, that will put us, we think, in a really good position. We're working with L3 Harris on that. We have a bunch of partnerships with some pretty big companies, NVIDIA and Intel and HP and so forth. But the one with L3 Harris, they are really, working with us very closely.
This is a complex business. There's a lot of moving parts, including, even on the business front, dealing with, defense contracts is challenging. So there's a lot of frictions that I'm sure you're up against, and it's fast moving technology too, right? So, getting up every morning and grinding away at a problem like this is not for the faint of heart. I'd love to understand what's your why? What gets you out of bed? Why do you do this every day and stick with it?
I just get excited about it. I mean, honestly, I had thought, do I want to do? I mean, I got to tell you, I'd said, there's no way I'm doing a startup. No way. Because, like, I've done buyouts, right? I mean, startups suck. But I get so motivated by the this technology and our AI are just so cool. And the amount of impact that you look at NERPAC, the amount of impact that could have on the world is enormous. And it's kind of like, honestly, I want to make my mark. I want to be the guy who pushed it and got it to happen. And now suddenly data centers are 40% more efficient. I mean, think of the impact of that.
It's dramatic.
It's gigantic. And so, yeah, I get really motivated by that stuff. It's just exciting.
When you think about the next 2 to 3 years, with the fundraise that you're currently working on, what's success look like for you in the company?
So I think two things. One, we get a big partner with NERPAC that it probably looks like a large institutional investment that really pushes, which because we're like a lot of small companies with great products. You need distribution. Our stuff in the hands of NVIDIA or in Google's hands or something. Well, we've got some real chops when it comes to building the product, and some in selling it. But we're a pipsqueak compared to somebody like a Google, right? Or you think of AWS. Think of AWS or anybody else with a cloud, or Google or Azure. Those, if they had NERPAC, they could say to their customers, we'll push this out into your devices and for an extra fee, and we'll encrypt your data, which you can't do otherwise, and we'll allow you to send a lot less data over whatever it is, and so you're going to pay less to send it to us. I mean, that seems like a pretty good deal, and we'll charge you very little to do it compared to the value that it's delivering. That's that's a big deal. So what do we need? We need to get ourselves to a point where we can sit in front of those guys and say, look at what we can do for you.
For those investors who are kind of on the line, they're thinking about investing, they're not there yet, I'll give you the last word. What do you want them to know?
We have our head in a place that says we're investors too. We think of ourselves as shareholders first. We're not tinkering. We have a real product, and we're really out there selling it. And and it comes down to this: the potential of it is huge, but you don't get there by tinkering and inventing. You get there by execution. As you said, that's the hard part. But we've got the people, and we've got the progress, and the AI is something that could be enormously impactful down the road. The Navy's interested, others, but fundamentally, we have to make NERPAC into something that is big, and we have the right people to do that.
If you liked what you heard on the show today, you can learn more about why Atombeam scored a 4.9 out of 5 in their last round on the KingsCrowd proprietary rating scale at KingsCrowd.com. And you can also reserve shares on Start Engine in their current Testing the Waters round. And as always, if you liked what you heard on the show today, please like, subscribe, and share our podcast wherever you listen so more investors like you can find us. Thanks for tuning in, and happy investing.